Okay, so lesson 8.4, more hills than SAAS, along with geometric mean. We got 1, 2, and 3 here dealing with geometric mean. So remember, the geometric mean is a over x equals x over b, and that will get converted to x equals the square root of ab. And then let's see, number 2 is kind of where we have a fraction here. So x equals the square root of ab. I'm going to call 4 over 5 a and 2 b. So I have x equals the square root of 4 over 5 times 2. And since I have a fraction and a whole number, I'm going to multiply. So that's 4 times 2 over 5. So that's the square root of 8 over 5. And then knowing my radical rules, my properties, I'm going to convert the square root of 8 over 5 to the square root of the square root of 8 over the square root of 5. Know that we cannot have a radical in the denominator, so I'm going to rationalize the denominator. So I'm going to multiply the bottom and the top by root 5. So I have the square root of 8 times the square root of 5, which is the square root of 8 times 5, over the square root of 5 times the square root of 5, that's 5. So I can break this number down, because now what I have to do is I need to simplify this radical up top. So I have the square root of 4 times 2 times 5, because 4 times 2 is 8. And then I'm going to have that over 5. Wow, we need more room. So the square root of 4 is 2. So I'm going to put 2 here. And then what's left over are the 2 and the 5, and they'll remain in the radical. So I have 2 root 10 over 5. Now I'm going to look at this fraction. Do I need to simplify this at all? No. So basically, this 2 root 10 over 5 is my answer. Number 3, I have 4 root 3 over 5 and 5 root 3 over 5. So I'm going to call this a, b. So x equals the square root of 4 root 3 over 5 times 5 root 3 over 5. So just going to look at the top stuff. I'm going to multiply the coefficient to coefficient and then the radicand to the radicand. So then x equals the square root of 4 times 5 is 20. And then root 3 times root 3 is just 3. And then I am going to multiply the denominator. So when I'm multiplying, I multiply across just like I did up top here. So I have 5 times 5, that's 25. So then I have x equals the square root of 20 times 3, that's 60, over 25. So then what I'm going to do is I'm going to rewrite this as x equals the square root of 60 over the square root of 25. And y'all, the square root of 25 is 5. And then the square root of 60, I need to break down. Well, let me check and verify if I need to break that down. Okay, so 10 and 6, because the two numbers that multiply together to give me 60 are 10 and 6. I can break down this 10 with 5 and 2. And then over here, this is 3 and 2. So I have a pair of 2's. So 2 is going to go outside of the radical. And then what's left over are 5 and 3. So that's 5 times 3. So 2 root 15 over 5. And that is your answer. Okay. Let's see. We have 4, 5, 6. It says to find x, y, and z. Okay. So I can probably just do an example of, let me see if I have something else at my disposal. 1 second. 1 second. Pulling up our key right now. Okay. So I just saw 4 and I'm seeing 7, so I'm gonna go ahead and do number 4. Okay, so we have a right triangle with an altitude. So one thing that you have to do, always, or my suggestion, would be to label your figure. So we have the hypotenuse. We know that the hypotenuse is across from the 90-degree angle, and I'm talking about this right triangle, this whole figure. What is the whole figure's hypotenuse? It's right here, not this one, okay? That's this figure. We're talking about the whole figure here. This is the hypotenuse of that original, or that, you know, big right triangle that we see. So this is the hypotenuse. I'm going to label that h equals 9 plus 3, which is 12. So that's 12. And then this is segment 1. This is segment 2. This is leg 1, leg 2, and there's the altitude. So I write H, L1, L1, S1. And then I have H, L2, L2, S2, S1, A, S2. The hypotenuse is 12. Leg 1 is X. And then segment 1 is just 3. So then, just only with one variable, I can go ahead and create my proportion here. Cross multiply, x times x is x squared equals 12 times 3. Take the square root on both sides. X equals the square root of 4 times, actually, 12 times 3 is 36. So x is equal to 6. The square root of 36 is 6. 36 is a perfect square. That's wonderful. Now let's go ahead and figure out this one. Hypotenuse is 12. Leg 2 is y. Segment 2 is 9. Great. 12 over y equals y over 9. Cross multiply here. Y squared equals 9 times 12. Take the square root. And break that 12 down, because I know 9 is a perfect square. So hold for a second. I have 9 times 4 times 3. 4 times 3 is 12. And look at that. I have 2 perfect squares here. So, oops, got to take the square root of y squared there. Okay, so y equals the square root of 9 is 3. And then the square root of 4 is 2. And then I have that 3 left over. So that is 3. So y equals 6 root 3. Y is equal to 6 root 3. Segment 1, altitude, segment 2. Segment 1 is 3. The altitude is z. And then segment 2 is 9. So 3 over z equals z over 9. So z squared equals 3 times 9. Take the square root. So that looks like z equals 3 root 3 to me. Yep. So z is equal to 3 root 3. So that wasn't that bad. Okay, so let me do 7. 7 has a lot of weird numbers as your answer. So I'm going to go over those real quickly. So again, this is the hypotenuse, segment 1, segment 2, leg 1, leg 2, altitude, H, L1, L1, S1, H, L2, L2, S2, S1, altitude, altitude, S2, hypotenuse is Z, leg 1 is Y, segment 1 is 2. There are too many variables in here. You cannot create a proportion with this just yet. So the hypotenuse, leg 2, S2. We have Z, leg 2 is Y, segment 2 is 2. Okay, again, we're dealing with variable. Oh, whoa, 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 whoa. Oh, I apologize. Leg 2. I was looking at leg 1. So hypotenuse is Z. Leg 2. Well, there's nothing for leg 2 here. So I don't necessarily need to use this at all. Segment 1, altitude, segment 2. Okay, so I just want to make sure. This right here, we don't have a leg 2. I guess we don't need this anymore. We were not going to worry about hills with the 2s. So we're going to move on to segment 1, altitude, segment 2. Let's see if it's going to help us with, the rest of the problems here. So segment 1 is 2, the altitude is 3, and then segment 2 is x. Perfect. We only have one variable here. So the game plan here is I'm going to solve for x. Once I know what x is, that's going to help us figure out what z, because we have parts plus part equals, the whole thing here. So this is 2. So 2 over 3 equals 3 over x. So 9 equals 2x. So x equals 9 over 2. Or 4.5. Okay? So I have... Actually, I'm going to write 4.5. Why not? 4.5. So this is 4.5. So then that means that z has to be 4.5 plus 2. That's 6.5. And then everything remains the same. So 6.5 over y equals y over 2. Y squared equals 2 times 6.5. Take the square root. And, okay, well, look at that. I'm multiplying this whole number by this, this decimal. So I don't want to simplify the radical. I'm actually just going to take the square root of that. So second square root of 2 times 6.5. That is, wait a minute. Hold up. I have 2 times 6.5. That's 13. Okay, so never mind. So y equals the square root of 13. Great. If this was like, I don't know. If you get something like that, like if you're multiplying, these two decimals together, then I guess just take the square root of that number. Like actually take the square root of that number. But here, 2 times 6.5, that's 13. What's the square root of 13? Well, that's the square root of 13 simplified. So I don't really necessarily need to go further on with that. Okay, so I have x, y, and then I need to specify that z is 6.5 because, again, z is this whole thing. That's 4.5 plus 2. That's 6.5. Okay, so hopefully that will help you with, or this video will help you with number 7. Okay. Okay. So number 9 is weird. So I'm just going to label this. We can see that this is segment 1. I hope, from all the labeling that we've done, you can recognize that part is segment 1, and then this is segment 2, and then this is the altitude. So I'm really using SAAS for this problem. So 24 over W plus 4 equals W plus 4 over 6. Now, 24 times 6 is... I have no idea what 24 times 6... Is that a perfect square? Let me check. 24 times 6 is... 144. Oh, perfect. Okay, so if I multiply these two numbers, that'll give me 144. So I'm going to put 144, not on the left-hand side. I'm going to put that on the right-hand side. And then I have W plus 4 times W plus 4. That's basically W plus 4 twice, right? And then remember, with algebra, if you have something like this, right, and you have to take the square root because you want to get x by itself. So that would be x equals plus or minus 12. Right? Hopefully you remember that from Algebra 1. When you take the square root on both sides, you need to make sure that your answer is in the form plus or minus. this, I can do the same thing here, and you definitely did. I don't know, actually, I don't know if you learned this in Algebra 1, but I know for sure you're going to be doing this in Algebra 2. You have w plus 4, the quantity squared. What I'm going to do, since I have this equals that, I'm not going to, rewrite w plus 4 twice and then FOIL and then do the x method. In fact, I'm going to follow this rule. I want to eliminate that exponent of 2. I'm going to take the square root on both sides. So the square root in that 2, that will go away. That's awesome. I'm left with w plus 4 on the left-hand side. W plus 4, that expression is alone on the left-hand side. And that's going to equal to the square root of 144. But remember, I'm taking the square root on both sides. So if I'm taking the square root on both sides, I need to have that plus or minus 12. Okay? So you're basically dealing with two equations here. W plus 4 equals that positive 12, and then w plus 4 is equal to that negative 12. If I subtract both sides by 4 over here, w is going to equal 8. And then over here, if I subtract both sides by 4, well, w is equal to negative 16. But what is the best answer? Our best answer, since we are dealing with a geometric figure, that means that we shouldn't have any negative side length whatsoever. So our best answer is the positive one, w is equal to 8. And I highly encourage you to, think about what I just did here, because this is going to prepare you for Algebra 2. I guarantee you that, okay? So please, take a moment and just synthesize what is going on over here. Okay. Okay, I notice we have some word problems. Golly, we have some word problems here. I need to think about my game plan. Okay, so 11, a museum has a famous statue on display. Okay, so this is the statue. The curator places the statue in the corner of a rectangular room and builds a 15-foot long railing in front of the statue. Use the information below to find how close visitors will be able to get to the statue. Okay, so we have I assume this is the hypotenuse. This whole thing is, okay, yeah, this is obviously the hypotenuse. What am I saying? This is the hypotenuse. This is 12 feet, and then this is 9 feet, and then here's my altitude. Okay. So, hypotenuse, altitude, leg 1, leg 2. So, what am I doing here? What is the best thing to do? Am I missing something? All right, let me, just in case, I'm going to call segment 1 X. I'm going to call segment 2 Y. And okay, so I'm going to try this. I have H, L1, L1, S1, hypotenuse being 15, leg 1 is 12, and then segment 1 is X. Because what I need to do is I need to figure out what this thing here is. Okay? But this is dealing with the altitude. This is dealing with the altitude. And the only formula that we can use or that involves the altitude is SAAS, right? But we don't have a segment 1 here or a segment 2. So I need to use both hills before I get to SAAS, if that makes sense. So I will do 15 over 12 equals 12 over... Actually, that's a horrible idea to call that X, my bad, because we already have an X here, right? So I'm going to call this I'm gonna call this B. I'm gonna call this R. Okay, my apologies. I didn't think this through. So here's an X, and we should use a different variable over here because we can't have two X's. That'll be very, very confusing. So we're gonna call this B. So that's B over here. So I have 15B equals 12 times 12 is 144. So B is whatever 144 divided by 15 is. What is that? 144 divided by 15, hit enter, 9.6. Okay, so that's 9.6. So segment 1 is 9.6. And then let's go ahead and figure out what segment 2 is. So HL2L2S2. And I called this R. I don't know why I changed that from Y to R, but whatever, it doesn't matter. 15, leg 2 is 9. Segment 2 is R. So 15 over 9 equals 9 over R. So I have 15R equals 81. What is R equal to? 81 divided by 15. Come on, let's figure that out. 81 divided by 15. That is 5.4. 5.4. So this is 5.4. Okay. So to summarize, segment 1 is 9.6, and then segment 2 is 5.4. So then we know that the altitude is just x. I'm going to use this. 9.6 over x equals x over 5.4. So x squared equals 9.6 times 5.4. I'm going to be relying on this calculator. 9.6 times 5.4, does that give me a decimal? It's 51.84. I am not going to simplify that. In fact, I'm just going to take the square root of that whole thing there. So that's square root of 51.84. Hit enter. Okay, I looked at the key, then I'm right. X equals 7.2. And the key that I'm looking at has no work whatsoever. It's just, everything just contains the answer. Okay? So, yep, that's how you do it. You have to exhaust pretty much all the formulas for this problem. Okay, so number 12, let's look at that. A bridge connects to a tunnel as shown in the figure. The bridge is 180 feet above the ground at a distance of 235 feet along the bridge. Out of the tunnel, the angle to the base and the summit of the cliff is a right angle. Okay, so one thing I want to go ahead and highlight is this. The bridge is 180 feet above the ground. So if this here is the ground and this is the bridge, then from there to there is 180 feet. So if this is 180, that means that this here is 180 feet as well. So one thing I'm going to go ahead and do is I'm just going to erase this so I don't confuse myself and think that this is 180 feet at all. So, all right, now that I have that, I'm going to label my figure. So this is the hypotenuse. This is segment 1. That's segment 2. This is leg 1, and then this is leg 2. So now I am going to think. What am I going to do? I can use SAAS here, right? So segment 1, altitude, segment 2. Segment 1 is x, altitude is 235, and then segment 2 is 180. So I have x over 235 equals 235 over 180, and cross multiply. So 180x is equal to 235 times 235, which is 235 squared. And I'm going to use my calculator. And I'm going to write 235 squared exactly on the calculator. And then I'm going to divide that by 180 because I'm solving for x, right? So here, x is 306.8, or really that's, 307 because I need to round that to the whole number here, round to the nearest whole number. So what is the height of the cliff? Well, that is... if I'm talking about, this here, that's the height of the cliff. That is 307. Okay, so that is, I'm going to write 307 there. Now, it says how high is the cliff from the base to the summit. So this here is what I'm looking for. It's essentially just 307 plus, so it's part plus part equals whole. That's 307 plus 180. So that is 487 feet. Okay. And then it says, what is the value of D? So I'm going to write the hypotenuse is 487 feet. So with C, got to find D leg 1. Okay, so HL1 equals L1 over S1. The hypotenuse is 487. Leg 1 is D. And then segment 1 is, what is that again? 307. Okay, let's cross multiply. You get D times D, which is D squared, equals 487 times 307. Okay, that's a huge number. And it says to round to the nearest whole number, so I can take the square root of, this. So if I take the square root, I have 487 times 307. Okay, so that's a decimal right there. So D is equal to 387. 387 feet. Okay, so that's 387 feet. That's my answer. Okay, now that I did number 12, what I want to go ahead and do is I'm going to go look at number 5 real quick. So I have a right triangle with an altitude. I'm going to label this. So this is the hypotenuse. That's x plus 2. This is segment 1, segment 2. That's the altitude. Leg 1, leg 2. So, okay. What's my game plan here? I have something here. That looks like a SAS right there. So segment 1, altitude, segment 2. Segment 1 is x, altitude's 5, and then segment 2 is 2. X over 5 equals 5 over 2. Okay. Oh, wait, hold up. Let's see. X, 5, 2. 2x equals 25. So x is, what is x equals to? 25 over 2. Or, well, 25 divided by 2 is 12.5. So x is equal to 12.5. So if that is 12.5, then the hypotenuse is 14.5. 14.5. Okay. Then I'm going to go ahead and find y. So h over L2 equals L2 over S2. So the hypotenuse is 14.5. Leg 2 is y equals y over 2. So y squared equals 14.5 times 2, which is y squared equals 14.5 times 2 is 29. Take the square root. Y is equal to y is equal to the square root of 29 because I can't break down 29 at all. So that's my answer. And then for z, let's see. So it is h over L1 equals L1 over S1. So the hypotenuse is 14.5 over your leg 1 is z equals z over 12.5. And if I cross multiply here, you should get, what's 14.5 times 12.5? 181.25. Okay. 14.5 times 12.5. I'm going to take the square root of that. Why not? 181.25. That's 13.5. Okay, so if I cross multiply, I get z squared equals 181.25. Take the square root. Z is equal to 13. I'm around 13.5. That's your answer, 13.5. So let me go ahead and verify with the key. What do they have on the key? Okay, so they have Z is equal to 5 root 29 over 2. Let me just see that. 29 over 2. Yeah, that's the same answer. Okay, perfect. Z is equal to 13.5 it is. All right. That's number 6. Oh, nope, just kidding. That's number 5. All right, toodles.